So we know that water does not conduct electricity. The stuff in water does, like salt, sodium chloride. But why? It's time for a quick chemistry lesson, but don't go away. If that intimidates you, don't worry. Don't think of it as chemistry. Think of it like Lego. Simple chemistry is just like Lego. You can put the Lego together, take them apart, put them together in a different pattern, take them apart again. Now there's fancy chemistry, but we don't need fancy chemistry. Simple chemistry, simple basic reactions are almost literally just Lego in terms of understanding. You don't need to know all about these bond angles and blah, blah. Let me show you. What is water? H2O. We know what atoms are. There's hydrogen atoms, oxygen atoms, all these atoms. 2 atoms of hydrogen, 1 atom of oxygen. That's a water molecule. And it's like this. Obviously, this is 2D. A molecule is 3D. We get the concept. So an atom has protons, and it has electrons, and it has the same number of them. Hydrogen is 1 and 1, oxygen is however many. Whatever its atomic number is, it's N protons and N electrons. It's electrically neutral. Water molecule is electrically neutral. This is why it does not conduct electricity. It is not a charge carrier. An electron can conduct electricity because it is negatively charged. When it moves, there is a moving electric charge. Water molecule is moving all the time, Brownian motion, do-do-do-do-do-do-do. But even if you're pouring the water, you're still not creating electricity because it's not a moving charge. Each proton and each electron is, but they cancel. But there's a trick to it. These bonds, there's 2 kinds of bonds, covalent and ionic. Except it's not really 2 different kinds of bonds. We just call it covalent when it's mostly covalent and not so much ionic, and we call it ionic when it's mostly ionic and not so much covalent. So what does that mean? Covalent. Covalent. Covalent means when you have 2 atoms next to each other, there's an electron from one and an electron from the other, and they kind of swap back and forth. And every chemistry student and every physics student is now screaming, I'm explaining, I'm not teaching, calm down. Basically, when you have a covalent bond, the electrons are kind of just going back and forth having a little party, and the atoms stick together because of that, but they don't really change. They don't really get charged in any way, it's just they're linked by these shared electrons. Ionic. Ionic means that only 1 electron, pretty much, has gone over. In this case, water is bonded ionically. And where's my doggone eraser? So like I said, they're electrically neutral. You've got positive on each of these, that's the protons, and you've got negative on each of these, that's the electrons. Same number, electrically neutral. But due to the peculiarity of the structure, physics, blah, 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 due to the way that oxygen and hydrogen interact, the electron, see the proton doesn't move, because that's what the atom is, but the electron goes up here, and this electron goes up here. It's still electrically neutral, because the electron just moved. It's basically over by the oxygen. The oxygen is grabbed onto it because of the peculiarities of the physics. So it's still electrically neutral. If the water's moving, nothing's happening because you've got equal protons, equal electrons, and everything cancels out. But they're sticky, see? The hydrogen here, at this part of the molecule, on that side, there's a positive charge. And over here, there's a negative charge. So the molecule together, it all cancels out. But if you have a negative charge over here, it's going to be attracted to this hydrogen, or it's going to be repelled from this oxygen because the oxygen is negatively charged because it's got extra electrons. That's an ionic bond. And that is also how water dissolves things, because even though it's neutral, it's sticky and it can grab things. So we have something else. It's called NaCl, sodium chlorine, sodium chloride salt. This is another ionic bond. Sodium, chlorine, don't worry about the shape of it, just physics. So you've got your positive and your negative, just like before. It's electrically neutral, but it's an ionic bond. This electron on the sodium, whoop, goes over to the chlorine. So even though it's electrically neutral, the sodium end over by the sodium physically is a positive charge, so it's sticky. This will attract electrons, and the chlorine will repel electrons, so it's pushy, or you could say it's sticky for positive charge. So if there was another sodium over here, it would attract the sodium, but it wouldn't do anything. NaCl is the stable form, so it's not going to make Na2Cl2 or anything. This is the stable form, but it's an ionic bond. So what happens when you have ionically bonded water and ionically bonded salt in the same container? They rip apart. The sodium is positively sticky. The oxygen is negatively sticky. And the oxygen bond is stronger than the sodium bond, for details of physics. The hydrogen is positive, the chlorine is negative, so that sticks to that. So these water molecules will grab onto the sodium molecules and then rip them apart. And you get sodium ions and chlorine ions. What's the difference between an atom and an ion? It has charge. What happens is, remember how that electron went over the chlorine? Well, when the water ripped it apart, it didn't put the electron back. The electron stayed over at the chlorine, it ripped it apart, very rudely in fact. So when the NaCl forms, the sodium and the chlorine are both electrically neutral. They're all fine, they're not ions. They combine together and then the water rips them apart and now they're ions, which means they are charge carriers. They are not electrically neutral anymore. All ions can carry electricity because they're charge carriers. I will discuss that in a future video. Right now I'm talking about the chemistry. Let's stick to that and then we can get to the current carrying later. So the water molecule is ionically sticky, and this is ionically sticky, but it's weak enough that it gets ripped apart. And you just have these ions floating through the mix. And then, just again, Brownian motion, room temperature, they're wiggling around. Sometimes they'll stick back together and you'll get your salt back. And then they'll get ripped apart again. So again, if you just have salt water sitting there, not really anything is happening. Chemically, breaking apart, putting together, blah, blah, blah. And that's what solubility is. Solubility is how much salt you can put in the water before you can't put any more salt. So basically there's a certain rate based on temperature and all this other stuff. The water is going to rip apart the sodium only so fast. It's only going to dissolve the sodium so fast because it's also going to be accidentally recombining. So if you put too much salt in, there's not enough water molecules to rip it apart as fast as they're recombining just from random chance. So then you get salt in the bottom of your bowl or cup or whatever because the water's just not fast enough. And then if you add more water, then it dissolves. So it's breaking apart, recombining, and so forth. Random chance. They're just moving really fast. So on our scale, on a human scale, it happens very fast, even though, there's these giant gaps between molecules and all this other stuff. On our scale, everything's going so fast that chemistry actually happens. If you want it to happen faster, make it warm, because the molecules move faster, and so they get into collisions faster. That's what it is. Also, they have more energy, so they rip apart faster, so all of it. But there's something else that happens too. H2O. So we already know that H2O is an ionically bonded molecule. That's why this works. What happens when water attaches to water? Because it does. Well, you get this. Hydrogen and hydroxide. One hydrogen rips off, and it has its electron stuck on the oxygen over here, leaves without it, and then your hydroxide is over there. The hydroxide doesn't really do this, just because now you've got a negative charge, a really strong one, and it's repelling and blah, 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 because it's electrically charged now. But water does basically dissolve water. Water dissolves itself. It just only does it a teeny tiny bit because the weaker bond of the sodium chloride, the salt, is easily broken by the hydrogen, oxygen of the water. It's much easier to rip the salt apart. So the water rips itself apart, but then accidentally recombines just like the salt. And water is not very soluble in water. So it recombines a whole lot faster than it rips apart. So normally nothing's happening, Sometimes this will form and then just stick back together. But sometimes you could have a sodium and a hydroxide together at just the right time, and then they'll make something called sodium hydroxide. What a name. And then they'll get ripped apart again. So again, salt water, nothing really happens because it's ripped apart, put back together, no big shakes. So that's what dissolving is. That's just what dissolving is. It's because of the ionic bonds, because of the shapes of these molecules, where one of the atoms has an electron sneak away and have a sleepover on the other atom, which gives them sticky ends, which stick to other sticky ends, and it ends up ripping apart into ions and then recombining in this constant dance of Brownian motion. So how do ions conduct electricity through water? It's by a process called electrolysis. And all you have to do is apply a voltage across the water with the salt in it, and you'll get electrical flow, and chemistry will begin to happen. This neutral solution where things split apart and recombine and it just stays overall neutral, it doesn't stay neutral anymore because you apply the voltage and things start to change and you break it out of this stasis. But that's for the next video. I've chosen to break these apart just so it's one topic per video, even though the videos are kind of short. Listen, I haven't put a video out for 2 months. It's okay. So next time, electrolysis. Let's put some electricity across that water. And until then, I'll be seeing you.